Welcome back to another digital SAT math lesson. Here we're talking about systems of two linear equations today. Some of the concepts we'll be going over would be substitution, elimination, number of solutions, and word problem translation. First things first, how do we solve systems of linear equations? There are two methods. The first one, substitution, and it's usually when one variable is already isolated. For example, if you already know y is equal to 2x plus 1, and you have another equation, 3x plus y is equal to 11, then here, in the first equation, you can see that y is already isolated, which means we can simply substitute this expression here in 3x plus y, and we can get 3x plus 2x plus 1 is equal to 11, um, which gives us 5x plus 1 is equal to 11. So we know 5x is 10 or x is 2. And then you can find the y from there, of course, because you know y is equal to 2x plus 1. So that gives us y is equal to 5. The other method is elimination, and that's usually when you can somehow match the coefficients. Sometimes if two of the two equations have at least like one variable that has the same coefficient. For example, here you have plus 3y minus 3y. So both of them have 3 with opposite signs. So what you can do is you can add them, and if you add them, then this plus 3y and this minus 3y, they cancel out perfectly, and you end up with 6x is equal to 18 or x is equal to 3. And then, of course, from there, you can find your value of x, or rather y. You can find your value of y, which ends up being 2 if you plug it into any of these. For example, if we plug it into the first one, then we get 2 times 3 plus 3y is equal to 12. That gives us 3y is equal to 6 or y is equal to 2. So sometimes you might be asked how many solutions there are to the system. And again, like the single equation case, we have three different possible cases. One is one solution, and as we discussed earlier, that essentially corresponds to two lines intersecting at a single point. So if we have two lines, maybe one's this blue line, and maybe the other one's a green line, and they intersect at a single point here, then that is a system with one solution. No solution, we know that's when two lines are parallel. So if we have these two green lines that have the same slope, then we have no solution to the system because they have different y-intercepts, so they never intersect. And finally, infinite solutions is when we have the same line described twice, maybe two different equations, like we saw in the standard form. For example, you can say 2x plus y is equal to 3, and you can say 4x plus 2y is equal to 6, and they both describe the same line. So in that case, they have every single point in common, so infinitely many solutions, and you have to compare the ratios of the x coefficients and the y coefficients. For example, in this one, what's the x coefficient? 2. What's the y coefficient? 1. 2 over 1. Whoopsies. That would be 2. What about this one? Here, x coefficient is 4, y coefficient is 2. That again gives us 2. That means these two lines are parallel. Now, from there, how do we know that if this has one solution, oh, sorry, if this has zero solution, or if this has infinitely many solutions? So the way you figure that out is you look at the C. So in this case, for example, we have 3 and 6. That's our C. So if we do, for example, we can do 6 over any of these. So in this case, for example, we're comparing the relative ratios of the coefficients, right? So here we can see that the x coefficients are doubled essentially from this equation to that equation. So here we can see that 2 times 4 is 2, sorry, 2 times 2 is 4. Similarly here, 1 times 2 is 2. So the x coefficient of this second equation is twice as much as the x coefficient of the first equation. Similarly, the y coefficient of the second equation is twice as much as the y coefficient of the first equation. And then if we look at the c value, we can see once again we have this times 2 factor. So here this is times 2, that is times 2, and then the C is also doubled, which means that they describe the exact same line. Now, if we had here instead of 4x plus 2y equal to 6, if we just tweak it a little bit and we say 4x plus 2y is equal to 7, then suddenly we can see that if we compare the x coefficients, what do we get? We get 4 over 2. If we compare the y coefficients, we get 2 over 1. So they're both equal to 2. But if we compare the two c's, if we take the ratio of the c's, then we get 7 over 3, which is not equal to 2. And in that case, we have two different lines that are parallel, but they're distinct. They have different y-intercepts. And in that case, we have no solutions. And finally, if we have a case where a1 over a2 is not equal to b1 over b2, for example, if we have 2x plus y is equal to 3, and maybe 3x plus 7y is equal to 4, then the the ratio of the x coefficients or the a values, that'll be 3 over 2, which is not equal to the ratio of the y coefficients, which is 7 over 1. So in this case, we already know that these two lines are not parallel. And when two lines are not parallel, for example, here, this blue line and this green line right above it, we know that they intersect at only a single point. So that's our unique solution to the system. Now let's do a practice question really quick. An online bookstore sells novels for $4 each and magazines for $1 each. Sadie purchased 11 total items for $20. How many novels did Sadie purchase? Now, we can write down equations based on this. And this is the part where you have to be a bit careful with word problems because half the battle is really just writing down the correct equation. And we worked on this in the last video. We know how this works. So she sells one novel for $4. So we know whenever we see for $4 each or $4 per novel or some kind of reference to a rate or a price, per piece or per unit, we know that corresponds to our slope. So in this case, we have essentially, let's call it the selling price. So let's say S is equal to 4N. And then we have magazines for $1 each. So that would be 1M. So our total selling price is 4N plus 1M. And then she purchased 11 total items for $20. So the bookstore for sells novels for $4 each and magazines for $1 each. So then how much money did she spend in total? 4N plus 1M, where N is the number of novels that she bought, and then M is the number of magazines that she bought. So that's our function S. And we know that this in here we know the second condition, that is the number of items that she bought in total, that is 11. So that would mean n plus m is equal to 20. What else do we know? We know with the value of this function s, we know how much money she actually spent in total, and that is $20. So we can go ahead and set that equal to 20. And now we have a system of two equations. We have 4n plus 1m is 20, n plus m is 4, sorry, we have 4n plus 1m is 20, and we know n plus m is equal to 11, actually. Let me clean that up really quick. So we have 4n plus 1m is 20, and we have n plus m, 11. So now we can go ahead and try to solve this system. So one thing you should remember is that whenever the coefficients match, you should try to eliminate. Here, we have 1m here, or we can just write that as m, 4n plus m, and we have n plus m. So the m coefficients match perfectly. So we can just go ahead and subtract equation 2 from equation 1. So we can just go ahead and subtract 2 from 1. 4n minus n, we get 3n. M minus m, we get 0. 20 minus 11, we get 9. That gives us n equals 3. And then we can go ahead and back substitute. The easiest way to go would be the second equation. So that gives us 3 plus m is 11. So then m must be 8. So how many novels did she purchase? That was the question. We know n is equal to 3, so the correct answer is B. The golden rule would be define variables, write two equations from the given information like we saw, and then try to solve it. And always check if your answer satisfies both equations, which we can just go back and try to do here. If we substitute n equal to 3 and m equal to 8 into the first equation, we get 4 times 3 plus 8. That gives us 4 times 3 is 12 plus 8, that's 20, which matches what's said in the question. And then n plus m is 11. 3 plus 8 is indeed 11. So as always, keep practicing, keep improving, and I'll see you in the next video.